Don't
Ah,
want me to come back.
that's so sad.
Yeah, he don't want to see me.
He said, "Can I come home?" And he said,
No, you have to start.
"Ah, that sounds tough."
Mm.
I'm counting days to 19 December.
You're counting down.
Want to come back?
Of course.
Pakistan, right?
No, something else.
Congratulations.
No.
You can come back. Oh, China.
You should get something for her. Are you the only one staying? Is anybody else staying here?
Yeah, I'm going to
This.
stay.
You're staying?
Yeah.
Same problem?
My father told me that to say.
Oh, your mother told
don't
you.
allow to go to
Okay.
Yeah,
China.
parents
And
problem.
her
Parents'
father,
problems.
because my mother, so she rather change the mind. Her father changed the mind.
I see,
Because
okay.
her mother.
Because of her mother.
Yeah.
So she's the problem. Okay, next topic now. Simple circuits.
So there was one Ohm's law.
No, I decided to put that in the next lesson. I split it into two.
Simple.
Yeah, got that?
No.
Yep. Okay, so simple circuits. I can go on? So actually I need to delete that, we're not doing Ohm's law. Right, now you don't need to write this down. You don't need to write this down. It's just understanding the English. What is an electric circuit? So an electric circuit is a path in which electrons, that should say flow, from a voltage or current, sorry, fix my English. An electric circuit is a path in which electrons from a voltage or current source flow. So in other words, a circuit is when electrons are flowing, moving. Electric current flow in a closed path called electric circuit. The point where those electrons enter is called the source, and the point where they leave is called the return, or the earth ground. So basically, I know there's a lot of English here, but what it comes down to is this. You have electrons, and when they're moving, if there's a battery here, this is called the source. And then when it goes back in, this is called the return. So you can see the electrons, they move around here. So this is called a circuit. Okay? Huh? Say again? LC? I don't know this. I know RC, AC, DC, but not LC. You said LC, didn't you? You'll have to write that down for me. I'm not sure. I'll check with you later. Yep. Okay. So look, here's a picture for it. So you see here, look, there's the source, the battery. These wires are conductors. Here is the return, goes back into the battery. And I actually didn't give you this vocabulary, but this light bulb is the resistor. Another name for resistor is called the load. I think this word is important because it is used a lot in circuits. Load means resistor. So like for example here the load is the light bulb. The light is the load. The battery is the source. The wires, they're conductors, and there's a switch. This is a simple circuit. Can you write down that word at least? Load. Load equals resistor, roughly. Okay. I'll go on. Huh? Load is the resistor. L-O-A-D
Yeah.
is a resistor.
And nothing.
Huh?
And
This is a new word, load. And source means like battery. Yeah, do you know the word source? Means like battery. I think load is a new word. Load means resistor. So you can write that down. Load equals resistor. Oh, you don't have to draw this beautiful picture. It's okay. You want to draw it?
She's drawing.
She's drawn? Okay. I'm going to go on. So, of course, we can't draw such a beautiful picture every time. Okay? We need a diagram to draw it simply but clearly. So, yeah, we have these special symbols that mean different things. Here are all the symbols here. Now, the first one, this is the symbol for a switch. This one is a cell. This one is a battery. I'll explain the difference in a moment. This is a lamp or a light. This is to measure voltage. You remember, voltmeter. This is to measure current, ammeter. This is a resistor. This is a variable resistor, meaning the resistance can be changed, adjusted. Finally, this is a motor. You don't actually really need this last one, it's not on the course. So just draw the first 8, please. The first 8. I will get to that in a moment, like I promised. I don't lie too much. Just sometimes.
Sometimes you have.
Sometimes it's necessary. You drew them all?
No.
No? Don't need the last one.
I know the like lamp for the
These are the new ones for you, yeah?
No, actually, no, sometimes you know in the
Yeah, okay, yeah. Okay, can I go on now? Not yet?
because there are resources.
They don't have to be that beautiful. Yeah. You're putting too much effort into them. The point is that you can do these quickly. Yes, yep. Okay, so remember the picture I showed you a moment ago with the light bulb, the switch and the battery. Let's draw that in this diagram. I'll go back to this in a second if you don't have it, okay? So, look. This is the light, and then there was the battery beside it. And then what was beside it as well? There was a switch. So this is what the diagram looks like. By the way, which way is the current going here? Up or down? Well, I didn't tell you yet, but
It's not a battery, it's a cell you draw a cell.
yes, now I need to explain the difference.
There was a cell, right?
It said battery, but there was only one of them, so it gets a bit messy now. Okay, I'll draw the two. Battery. Anyways, which way is the current flowing? Up or down? Well, I didn't tell you yet, but the big side is the plus side, and the small one is the minus. So here, this is plus, and this one here is the minus on the battery.
One more thing.
Yeah, it goes from plus, so it goes up, across,
One more thing.
through here. Yeah.
We have to opposite to the switch. We have to draw battery plus and we.
Which one is going to work?
Hold on. This current is, when the switch is closed, of course, the current is going around like this.
I'm stuck here.
Well, it'll look, if it's open, yeah. So let's close it, and the current will go through. Yeah.
But it's already passing through
Current always must go back to the return.
The end of the battery.
Yes. Current always returns to whence it came.
One thing is that we have always we have to draw positive to the towards like a cell, no sorry, bulb, which we're using something.
Usually, but you don't have to. But usually. Okay,
If we draw opposite thing.
that's fine. That's the work. Yeah. Okay. Can I go on? Yes? So that was your first circuit diagram. So we have rules when it comes to circuits, but before that, just some vocabulary. Series and parallel.
Yeah.
Two types of paths. There we go. So look, when the resistors are together like this, we call that series. But when they are together like this, we call that parallel. Because, you know, like in maths, it's parallel. Remember parallel. So please make note of these words. Series.
You have to draw.
Well, you can just draw this. Look. This is series. And then this is parallel. Series and parallel. This is series and this is parallel.
And that looks like a copy notebook.
Sorry, and what's the diagram?
Say again?
The diagram.
You don't have to. Just something to remember the difference between the two. Series and parallel. Yep. Can I go on now? Yeah. Okay. So now English time. English time.
Everybody's English time.
Yeah, but this is extra English time. So, just to be clear. Now, by the way, get off Facebook, would you? Status update. Teacher just punched me in the face for using Facebook. Lols. Now, just to be clear, I'm simplifying my English rules here. So if an English teacher was watching, I don't think they'd notice. But just to be clear, these are simple rules, but they'll work well for you, okay? One battery is not called one battery.
So called what?
We call it a cell. Okay, so we don't usually call one power source a battery, we call it a cell. Yep. Two or more cells together is called a battery. So remember in the picture you had a moment ago, that's why this is called a cell and this is called a battery, because one is a cell, more than one is called a battery.
So on the phone we call it battery or cell.
Well, this is the thing, when you look at your phone, you would think, oh, so I have only one, so this is called a cell.
Yeah.
But really, if you could open it up, you'll see there's actually many inside of it. So there's many cells inside the one battery. Yeah. So it can get complicated, but I think you probably really could call this a cell instead of a battery because it's one. Really. Okay. So you can say things like, I have a 3-volt cell. That's right. We're happy. You could say, I have 2 connected 3-volt cells, therefore I have 1 battery. That's right. I have 3 connected 3-volt cells, therefore I have 1 battery. That's also right. I have 2 connected batteries. This is wrong. You only have 1 battery, ever. Please don't say this. I have a 3-volt cell, therefore I have 1 battery. Right or wrong?
No, wrong.
Wrong, yeah. You need to have 2 cells to make 1 battery.
At least 2 cells.
At least 2. Please don't say this. I'm simplifying the English here, but these are fair guidelines, okay? So you don't have to write all of this. Just need you to understand how we're using the English here. So in other words, 2 cells in a battery. 2 cells make a battery, 2 or more. So please don't write all of this, write what's most important to you. If it is all of it, that's okay. God. Rio, get off the phone. Got it? Yeah? Okay. I'll go on.
Go.
Yes? Grace is okay? Yeah? So, complete the sentence for me. I have 1 cell. I have 2 cells, so that's a battery. 3 cells, battery. 2 batteries,
No.
fail. Yeah, okay, good. Now, we need to talk about some rules when it comes to circuits. So, when it's in series, the current is constant. So, let me draw what that means. So, for example, if you have something like this, the current here is the same as here. It's the same as here. So in series, the current is constant. I1 equals I2. This is like I1, this is like I2. They're all the same. Okay? That's fair enough? Yep. Resistance is additive. What that means is the total resistance, you add the 2 together. So again, if I go back here, if this is R1 and this is R2, then the total resistance is R1 plus R2. Makes sense, yeah? It seems familiar, yeah? Okay, next. Voltage is different and additive. So let me explain that one. Yeah, so I'll explain that. So for example, here,
You're talking all of them in series.
first one's in series, yeah. So here is a voltage on a voltmeter, we'll call it V1. And then this voltmeter says the voltage is V2. Usually, V1 and V2 are different. But if you were to calculate the total voltage between the 2 of them, it would be V1 plus V2, like this. So that's what I mean when I say voltage is different and additive.
Even resistance is different.
Usually, of course, unless you use the same material, but generally different.
So you're talking both of them in series.
Everything's in series so far.
Okay.
Is that okay, KJ? Makes sense? You understand what I'm saying here? Yeah? Okay, so voltage is different and additive. So V1 doesn't equal V2, and total V is V1 plus V2. Yeah? Okay, next. Battery. Or cells. Plus with a minus causes an increase. Minus with a plus causes a decrease. Let me explain with a picture here. So you know when you put your batteries in your toy, you usually put them in like this. This here is a minus, this is a plus, and you put this one in beside it like this. And this one's a minus, is this one a plus, And then, what is it? There's usually like a spring here.
Yes.
Yes. And then there's usually like a little thing here, isn't there?
Yeah,
Yeah.
exactly.
So, what I'm saying is, if this is 1.5 and this is 1.5 volts, then it's like having a 3 volt in total. Okay. But interestingly, if you were to put them in backwards, so for example, if you had something like this, let's say this is 6 volts and this is plus, but if you put another one beside it, and let's say this is like 2, this is plus, and this is 2 volts.
Be less.
Yeah, it will not be 8. What would it be? It'd be 4. If you put them in backwards, this one actually makes it smaller. If you put them the wrong way. Exactly, yeah. So, anyways, that's what I mean here. Plus with plus makes it bigger, but, sorry, plus with minus makes it bigger, but plus with plus and minus with minus makes it smaller.
Just
Oh, yes. Yeah, the same, reduce, opposite, add.
You should have a book.
No. You see, you think this because you don't have one. But I can tell you, from my experience with students previously, it doesn't make any difference. They had one in the past. It doesn't make any difference. Students think if they have a book, everything will be okay, their life will be better.
no, I have never used it. They give us, but I don't use it.
Yeah, exactly. So this is why I don't, because people don't use those.
It's really not useful.
It's good. The book is good for revision.
No, you see,
Is
again,
it?
you think this.
No,
No,
it's
no,
not.
no, no.
Notebook is good.
The problem is, anyways, Fahad, there is no book for this course. There's no book for it. I would have to give you a college book and then say you need to use 10% of it.
They will make your own book.
Yeah. Be creative.
You get videos, they're better than books.
Oh,
Yeah.
it's in video you have to like the book
Look,
you can just
hang on, you're all young. You all are into technology with your videos and YouTube. This should be great for
Video,
you.
can't jump.
Yeah. All right, can I go on now? Do you have this one? Yeah. Right, so now let's talk about parallel. So in parallel, current is different and additive. So let me explain that. Parallel current is different and additive. So what that means is, look, if you have here, this is current, this is current, we'll call this I1, and this one here is I2, but if they come together, then this would be, no, not this actually, it'll just be I1 plus I2. So that's what I mean, and usually I1 and I2 are actually usually different. So current is different and additive. That's what that means. Got that one? Yep.
Yeah.
Okay. Next, the reciprocal of resistance is additive. So what the heck does that mean? Let me show you. So if you have one resistor here, or 1, and one resistor here, or 2, the total resistance is actually, you can find it using this formula. This is the one you were thinking of, Karar, wasn't it? So this is the formula here. This is how resistance adds together in parallel. Some people have seen this before, I think. You got this formula? Yes? KJ, did you write this formula down? Yeah? Okay. So the reciprocal resistance is additive. Yep. Okay, next. Voltage is constant. V1 equals V2. So what I mean by that is, again, let's say, I don't know, you have something like this. So the voltage here, yeah, that the voltage in the top. Well, hang on. Yeah, I'll draw it like this. The voltage here and the voltage here, they're the same. So for example, no, we'll just leave it at that. The voltage is the same, top and bottom.
Series, you don't have voltage?
Huh?
Series?
We did. We said they add together.
You said no.
Yeah.
And then there will be the series.
Huh?
In the end it will be
That's
series.
right. Yeah. You mean if I do it like this?
Yeah.
Yeah.
Altogether, it's
Just
V as well.
Yeah.
What do you call this? All of it, voltage, all of it.
The topic, yeah, I suppose you can call it electronics or circuits.
Circuits.
Yeah,
Yes,
circuits. Okay. And lastly, battery. If battery is in parallel, we'll do it later. So we won't look at those situations in this lesson, because we are looking at simple circuits today.
Yes,
Yeah.
yes.
Okay, so let's have a look at some examples, I think. Yes? Okay. Right, so write this one down. Two 3-volt cells are connected in series to two resistors. If the resistors are in series, and then if they're in parallel. So write this down and we'll do it.
So that's
Yeah.
battery, right?
Very good. Yeah, 2 cells makes a battery. So before I do it, I would actually like people to draw the circuit for A. And I want to see if you drew it correctly. So I want to see the drawing for A first. Fahad.
I think some question you not give you a question, just drawing, and you have to calculate.
Yeah, now these we will do, and we'll definitely do more difficult ones later. This is using our Russian friend Kirchhoff. Do you know him? Have you heard this name, Kirchhoff? Kirchhoff's rules?
No.
No? Kirchhoff rule?
Maybe I
Kirchhoff?
said it in Arabic.
Kirchhoff. No?
Kirchhoff.
No?
No.
Can I see the picture? You're drawing it. Fahad, where's your diagram? Okay. Now have a look. Yes, but can you write the numbers in on it as well, so I can see? Okay. I want to see your drawing as well, please. Can you draw it before I do it? KJ, can I see your drawing? Where is it? What the heck is that? This is a resistor of 4 ohms. 4 ohms. What's the voltage here? Cross, is it? Is it three? Three in total? Is this your drawing? Not quite. Make these rectangles, because we don't know that they're lamps. You think you can try and draw the A part? Impossible? Okay, I'll draw it, so. Okay. What I want you to do, we'll go with Grace. Read the start of the question. What do I say?
2, 3 wall cells connected.
Good, stop there. So let's draw that first. Everybody look up. She said there are 2 3-volt cells. So this is 3 volts and this is 3 volts. So how much is that in total? That is 6 volts. Fine. Okay, continue please. In series, yeah, good, yeah.
2, 2, 4,
Good, so now this is connected to 2 4-ohm resistors in series. What is the total resistance here?
R1 plus R2,
No.
8.
8.
So it's R plus R2.
Yeah, yeah, it's 8, yeah. So the question is, if the resistors are connected in series, is it? What is the current?
The resistors are in series, then
Yeah.
calculate the total resistance.
Yeah, we've done. There it is, 8.
Okay.
And
The resistors are in parallel, then calculate the
Part B.
total.
that's part B.
Part B, yes.
Yeah. That's all I asking, is it the total resistance?
Yep, neighbor.
Yeah.
Here it comes.
So in the B part, they're connected in.
We also want the currents.
Okay, well that's what I mean. Yes, I want the current as well. Okay. So which way is the current going? Left or right? Current, left or right? Left. And what do we know about the current? It's the same everywhere. Yeah. Now, do we have a formula to calculate current if we know the total voltage and the total resistance?
Yeah.
V over.
Yeah, you have the triangle VIR. So I is V over R, which will be 6 over 8, which is 0.675 amps. Sorry, of course, 3/4, yeah. 0.75 amps. Now, the next part of the question is if the resistors are connected in parallel. So I'm going to remove this part. Can I remove this? Yeah. So the next part is now we have this, but this time they're in parallel. Okay, what's the total voltage here in the battery? 6 volts. Now this is a 4 and this is a 4. Is the total 8?
No.
No. You have 1 over R, not 1 over 2, I don't think so. 1 over 4 plus 1 over 4. 1 over R equals 1 over 2. So what does R equal? 2. So again, you can say I equals, what was the formula we used last time? Well, it's right there. V over R, wasn't it? So I is V over R, which will be here 6 over 2, which will be 3 amps.
Can you scroll down?
Here?
Yeah.
This is the only example I have to do, okay? Because it's not too crazy. Now, tell me, look at this one here. Oh, please, hang in there. Just 1 or 2 more minutes, please. This voltage, is it the same as this voltage? Yes. This resistance, is it bigger or smaller? Yeah, this is smaller. So, I go from a smaller resistance to a bigger resistance. I go from a weak phone to a smartphone with more resistance. What happened to my current? Did it go bigger or smaller?
Smaller.
Which is what we said earlier in the last lesson, wasn't it? Yeah. Even though the battery's the same, did I change the battery? No. But because I changed the resistor, it meant the current changed. Even though the battery stayed the same. That was the point I was trying to make in the previous lesson. I think with numbers you can see it a bit clearer now. Yeah? Okay. Can I go back to the slides?
Yes.
They need to go to Starbucks and get their new winter drink. What is it now? I think it's nutmeg and toffee and eggnog. Isn't that the new flavours today? Did you see them?
The red one.
The red ones, yeah. They have toffee, gingerbread, and eggnog, I think. You know these flavours?
You actually use egg.
Yeah, ever had eggnog?
Yeah, it's okay.
You had eggnog?
No, I mean I finished.
You got this? You should try it sometimes. You'll be surprised. It's quite delicious
Sorry.
and quite bad for you.
Quite well.
Why it's so delicious. Yeah.
Quite well.
Okay. Can I go back now?
Yeah.
Yes, that's the one. You can get it after class. Yeah. Okay. Whoops. Now I'll put this, now don't take the picture just yet because I need to change it a little bit. I'll put it up online. But just before you go, I just want to quickly look through them. The first one, you have 2 5-ohm resistors connected to a battery. What's the current? And these ones are in series. You have 4 3-ohm resistors connected in parallel to 2 6-volt cells. What is the current? Okay. Now this one's interesting. When the 2 resistors are connected in series, this is the resistance. And when they're connected in parallel, this is the resistance. So it's 2 equations with 2 unknowns. And in the last one here, there's a diagram. I give you the information, I give you the diagram, and then I ask you different questions. So this one, it has a parallel or series. What is these ones? Parallel or series? 2 and 3?
Oh, it's parallel.
Parallel.
Yeah.
And then when you put this one together with
Connect
this one,
to series.
series.
Yes.
And then there's 2 batteries, 2 cells here. Oh, don't say 2 batteries. 2 cells, 1 battery. It's recorded now. It's being put as evidence.
What's down? 2 batteries down?
2 what?
Yeah, you said.
2 what?
You said 2.
2 cells. 2 cells. That's right. 1 battery. 1 battery. Okay, I'll upload this later. I might change it a little bit, but this is the type of questions
So
you
the
get.
tails I have to add them.
Which one?
Cells.
Yes. Yes, like in the example I did, the voltage adds together.